So I did kind of that recap, like I said, at the beginning of last week, of hints as to what tells you what type of interest to use. So I want to look at tonight just doing some example problems and taking you through how do you pick out what type of which formula to use on that problem. So let's say that Kevin wants to have $80,000 in 20 years. How much should Kevin put away now at 8% compounded quarterly? Okay, first of all, first question we should ask is this simple interest?
No.
No, it's not. What tells us that it is not simple interest? The word compounded. You got it. But that's the first question we should always ask, because if it's simple interest, that usually means it's the simpler problems. But no, this is not simple interest because it has the word compounded. Our next question is single payment or regular payments? It is a single payment. Regular payments would be an annuity. This is not regular payments, it's a single payment, which means it is either a future value or present value of compound interest. Now that we know that it's compound interest and not an annuity, are we trying to find future value or present value? That's exactly it. We know how much Tim wants in the future. We want to figure out what Tim needs to, or Kevin, sorry. We know how much Kevin wants in the future. We need to know how much Kevin needs to start with right now to get there.
Kevin's isn't part of a witness protection program. Maybe that's why he goes like that.
There you go. It's just that point in the night for me. I start at 7:30 on Wednesdays, so by this point in the night, I'm getting loopy. So, exactly. Kevin has the future value, and we're trying to go back to the present value. So it's the 80,000 divided by 1 plus 8%, 0.08, compounded quarterly, so divided by 4 to the power of 80. 20 years quarterly, so it's going to be the power of 80. And that's it. It's that simple formula for this one. Oops, I multiplied instead of divided. Let's try that again. So Kevin should start with 16,408.78. So any questions there?
When is it ever 1 minus the rate? Or is it always 1 plus?
1 minus the rate would only be if it's in a discount situation.
Okay. And we won't really come across that with annuities, will we?
Not with annuities, no. If you were to do like balances adjusted for inflation or something like that, you'd do that as well. What is the real dollars, the real future dollars? But yeah, you guys haven't angered me enough to make you do that for this class. Still 2 weeks. Sam borrows $4,300 at 7.2% exact interest for 75 days. Find the amount Sam repays. What's the first question we always ask? Simple interest. Is this simple interest? Yes, it is. So since it's simple interest, it's I equals PRT. So Sam's interest is going to equal what? 4,300 times 0.072 times 75 over. Why 365 and not 360?
Exact.
You said that word exact interest. Remember, ordinary, or if it's not stated at all, it would be 360. But this one did say exact. $63.62 in interest. Do you guys get $63.62 in interest? Okay. So the 4,300, because we want the amount repaid, not the interest. So plus 63.62 is $4,363.62 that will be repaid. Frankie borrows $7,000 at 8.6% compounded monthly for 3 years. Bless you. Find the effective rate. You have to ask it. Simple interest? No, the word compounded is there. One payment or regular payments? Single payment. You got it. So this is future or present value of compound interest. Well, actually, we're looking at the effective rate. So effective rate only applies to future value. Technically, there's an effective rate on a present value, but we have to use future value to calculate the effective rate. So what do I do? It's compound interest. I don't use I. So I'm going to find a future value. What's my principal going to be?
7,000.
We can use the 7,000. Technically, in an effective rate calculation, it really doesn't matter, does it? But since they gave us 7,000, let's use 7,000. Times what? 1 plus 0.086 divided by 12 to the power of, this is where I'll get everybody. Why am I using 12? Because
It's over a year.
yeah, if it's the effective rate, we never go more than a year. So if it's more than a year, we figure 1 year. If it's less than a year, we use actual time. Oops, not 34, just 30. So do we get a future value of 7,626 and 30 cents?
Yep.
What's our next step?
Find the interest.
Find the interest. How to do that? Subtract the starting amount of 7,000. So we get $626.30 in interest. And then I equals PRT, which means $7,000 times R, because we're looking for a rate now, times, what's our time? 1 year. So we did go over a year, so we're going to use 1 for our time. 7,000 times 1 is just 7,000, so I'm not going to bother rewriting it for combining those. Our next step is going to be to divide by 7,000. So 626.30 divided by 7,000. 0.089471. Because my rate. Move my decimal point 2 spots. 8.9471%. I didn't tell you where to round, and if I don't tell you, what do you assume? Hundredths, so 2 decimal places. So 8.95% is the effective rate. All coming back to us now? On May 18th, Scott extends, and I'm not going to say to who, so I only have one name to mix up here, extends a $3,700 120-day note for 8.3%. On July 2nd, Scott discounts the note to a bank at 10.4%. Find Scott's proceeds. Simple interest? Yes, it is simple interest. They don't say compounding in here anywhere. Whenever you see the word discount, a discount note is a simple interest. Now there's simple interest and simple discount, but when you see the word discount, we're applying that. It's implying that simple interest calculation. Now this is a two-tiered problem. When we're discounting a note, remember we have those steps to follow. The first step is find the maturity value of the original note. To do that, we first find the interest. So the interest is, how are we going to find it? 3,700 times 0.083 times 120 over 360, because it doesn't say, so we assume ordinary interest. So we had interest of I believe it's 102.37. Okay. So what do we do with that? We add it on to the 3,700. $3,802.37 is the maturity value of that original note. Can anybody tell me what step 2 is?
Oh, we have to figure out how many days, what you didn't really say, okay, yeah, we have to figure out how many days it is that the bank takes it over.
Perfect.
Figure out the rest of the project.
Perfect. We have to find the discount period, and that's the number of days that the bank is taking it over. So, do you guys anybody have their table handy on page 396? May 18th is 138. July 2nd is 183. So we're going to do 183 minus 138, was it? That's 45 days, but that's the number of days gone by. Perfect. So we're going to take 120 days minus the 45 days gone by, which will give us 75 days left. That is the discount period. That is the single most common mistake made on these discounting a note problems on a test, is they find the days gone by and they use that as the discount period. It's the days left, the days that the bank is going to have to hold it. Who can tell me what step 3 is? Find the bank discount. And what do we use for the bank discount? It's going to be an interest calculation. But what do we use for the principal? Perfect. That maturity value of the original note, 3802.37. What's the rate? $10.4 is the bank's discount rate. So 0.104. The time? 75 out of 360. Giving us $82.38. That's the discount. What's the final step? Perfect. We find the proceeds. That is done by taking the 3802.37 and subtracting $82.38, which is going to be $3,719.99. So that's how much Scott is going to get from the bank. I think we've earned a break. So let's take about 10 minutes. So our next bundle of fun. Let's see. Kim borrows $4,100 at 6.4% on August 27th for 90 days. On October 8th, Kim pays $2,000. Find the balance after the payment and the balance due at maturity.
I wish you could read each question on the text with those inflections.
the sheer excitement I bring to it.
Well, it's one of a kind.
Sure. I'd charm everybody right to sleep, huh?
She's so credit.
That's why people have you do the morning announcements in high school,
There you go.
even middle school. I
Oh,
love
sure.
the inflection.
There you go. So simple interest, yes or no? Yes, it is. This is actually partial payments U.S. rule. So this starts on day one, of course, at $4,100. The next action is on October 8th, and that is the $2,000 payment. So we need to do some day calculations here. August 27th is
239.
239. October 8th, 281.
281.
So we have 42 days. Then what? The interest for the first 42 days. So I equals 4,100 times 0.064 times 42 over 360. What do we get? $30.61. Good. Then what? $4,100 plus $30.61. $4,130.61. What does that represent? That's the balance before the payment. So then, yes, we subtract the payment, 2,000, which gives us 2130.61, and that represents the balance after the payment. Is that one of the things we're asked for? That's kind of a really crappy hint. That's yes. Balance after the payment. Yep. The second thing we're asked for is the balance due at maturity. The next action is maturity. Got to figure out our days. Well, it was a 90-day note, and we've used up 42 days. So that means there's 48 days left. So then, $2130.61 times 0.064 times 48 over 360. And for interest, we get $18.18. And what do we do with that? We add it on to the 2130.61. We get 2148.79, which represents balance due at maturity. Any questions?
Why did we use 0.06? Where did we get? Yeah.
The 0.064?
Oh, I wrote it down.
Okay, no problem. Max invests $980 at 6% compounded quarterly for 9 years. How much will Max have after the 9 years? First of all, simple interest? No, it is not. Because it says compounded. Single payment or regular payments? Single payment. So that means this is just a future or present value of compound interest. Which one is it? Future value or present value? Future value. We know how much we have now. We want to know what they're going to have in the future. So that future value is going to equal 980 times just one. Remember, just compound interest. Single payment is just one parenthesis. 1 plus 0.06 divided by 4. Close parentheses into the power of 36. And that's it. Perfect. $1,674.96. Questions? Alex invests $150 per month at 8% for 12 years. How much will Alex have? Simple interest. Somebody's got it there. No, it is not simple interest. It does not say compounding, but it says per month. Per month implies regular payments. And when it implies regular payments, that implies annuity. Remember, compound interest is a single payment. So we need to know then accumulation phase or liquidation phase. Accumulation or paying in. So we're finding a future value. So that future value is equal to our regular payment, 150, times 3 parentheses, 1 plus 0.08, divided by 12, close parentheses, Power of 144. 12 years, 12 months per year is 144. Minus 1. Close parentheses. Divided by parentheses 0.08. Divided by 12 and close and close. $150. It's not working for you? So what do we get? $36,076.26. Good.
Yep.
Perfect. Chris borrows $4,900 at 7.3% for 110 days on a simple discount note. Find the effective rate. So back to our main question, simple interest? Yes. Simple and discount, yeah.
Can you tell me, so even though you've given us all this information of that 4,900, from what you're saying, we could put any number for an effective rate to find out what it is? Is that right?
Yeah, we could. Yeah, the 4,900 doesn't mean much here, but
Okay.
since we have it, we're going to use it. So to do this, for a simple discount note, the effective rate, first we have to find the discount. How do we find the discount? I equals PRT, so it's going to be 4,900 times 0.073 times 110 over 360. What do we get? 109.30. Perfect. What's our next step? Find the proceeds. Remember, this is a discount note. So we take the face value, the 4,900, and we subtract the discount. You get proceeds of $4,790.70. What's next? I'm going to find the effective rate using I equals PRT. Only what goes in for I? 109.30. What goes in for P?
479.
Our proceeds of $4,790.70. R? Well, that's what we're looking for. T? 110 over 360. What then would be our next step? Perfect. We're going to combine the 4790.7 times the 110 divided by 360. So 1463.825. Now again, that one came out to be a nice decimal that we can, type in exactly. But usually it's going to be an ugly decimal and we'll keep it in our calculator. So that's the next step. Divide by the 1463.825. Now, just to stay in practice, I'm going to keep that in my calculator. So what I'm going to do is I'm going to type in the 109.3 divided by second answer. So 0.074667 equals R. What do I do with that? Move the decimal. 7.4667%. I didn't tell you where to round, so we're going to assume hundredths. So 7.47%. That's our effective rate. How we doing?
Good.
Let's say Shelly needs $5,800 a month to live in retirement. Well, you never know. They might live in an expensive area. Shelly will retire at 62 and live to 97 and draw 4.3% in retirement. If Shelly is 34 now, how much should be put away each month at 8.8% interest? Do I even need to ask if this is simple interest? Sure. It's not. No, it's not simple interest. This is obviously an annuity problem. So we've got retirement, and we've got death. Our ages are, what's the age now? 34. Retirement, 62, and death, 97. From 34 to 62 is 28 years. 62 to 97? 35 years. Sensing a problem already, right? If you're retired for longer than you're paying in, you're probably in trouble, yeah. What about our rates? During the accumulation phase, what's the rate? 8.8%. Liquidation? 4.3%. Do we know either of the payment amounts? $5,800 a month in liquidation. So we're going to find the present value here. See if you can beat me to it.
You're going too slow.
I'm trying.
We'll just wait for you to get the answer.
Oh, come on, be brave. What'd you get?
Let's see. $1,258,278.44.
Works for me. Everybody need a second to finish punching it in before we move on?
I want to have ready to go.
Okay. Why is that so much money? Well, first of all, $5,800 a month is a pretty cushy retirement. Second of all, she plans on living for 35 years. Not that's a bad thing, but it's expensive. So what's our next step?
How many accounts she puts away each month?
You can find that monthly payment to pay in. So we got the 1,258,278 and 44 cents. What do we do with that? Divide by 1, 2, 3. I'll have you guys try to beat me to it again.
1 plus 0.088 divided by 12.
Anybody get an answer?
$866.70.
Perfect.
That's a month that she would have to put.
That's
away.
how much you'd have to put away, almost $900 a month to achieve that. But now you think about that, that's still a pretty good deal because she's only putting away for 28 years and she wants to draw out for 35 years. She's only investing or putting away $866.70 times 336 payments. So she's only put away $291,211.20. Which I know that sounds like a lot of money, but how much is she drawing out? Well, $5,800 for 420 months. So she's only drawing out $2,436,000. So she's still drawing out nearly 10 times as much as she put away, even though she only put away for 28 years and is drawing for 35. So this investment is a pretty powerful thing. Okay, I think I've done enough damage for the night intentionally. Do you guys have any questions about the test or about any of the stuff we covered before I let you guys escape?
Are we able to make test corrections before the next test?
Yes, you will be able to make next test corrections on the last test and on this next test. This next test I'll try to get returned to you as soon as possible. We'll be able to do corrections. That's what that last week is, 2 weeks from tonight. You'll be able to do test corrections that night, and there'll be extra credit questions for you that night. I can feel the excitement building. And yes, the test will be ready earlier in the day for you if you want to take it earlier on Wednesday. I'm going to try to keep them close to it.
You should literally use the same
I've actually done that before where I had a group where they weren't paying attention. So during the review, I've actually done questions right off the test. By the way, there is a new quiz due tomorrow, Thursday, at 11:59 p.m. And there is a new homework for next week. That is the last homework, yes.
There is homework or there isn't?
There is a homework.